Hello and welcome to this presentation of our project, which is the Game of Life. I am Saurabh Karel and my partner for this project was Tori. So why the Game of Life? When choosing which project to implement, we decided to choose the Game of Life as it presented us to a larger challenge. While the 15 puzzle did look equally challenging to implement, one of us had already previously implemented the 15 puzzle, meaning a portion of the challenge in creating the game would be eliminated. So by choosing the Game of Life, both partners felt like they were challenged with creating logic through JavaScript, HTML, CSS that they had never created before, such as updating board states based on a set of defined rules. Statement of the problem. One of the most famous games around is Conway's Game of Life, the mathematical model that showcases cell automata. With many models available to view and try, why would we need to create another version of this famous game? Not many versions, if none, incorporate a pattern availability that lets you set patterns at the start of your game that may change how your game would showcase. Thus, our goal was to build in a way to generate patterns into the game board at the start of the game, which may change how the game is played. General requirements for the project. The user would need to be able to start the game on either a random implementation of the board or one that showcases a certain pattern, either stop the game or pause the game to resume later, increment the game by one time, to skip ahead by a random number, our number was 23, and to reset the game if all the cells had already died. A player can expect to see a moving game board where cells would either be created, remain alive, or die based on the principles of the Game of Life. Group methodology. We use Scrum to help ourselves keep track of for this project. We first met to decide on a project idea and how to divide our workload. We got the main features implemented on an incremental basis, talking as partners every day to see what had been implemented and what was to come. After features were implemented, we worked on the front-end design, bug fixes, and general policing, and communicated where we needed help. Using Scrum benefited our project by allowing us to understand where each other was as we communicated with each other. It also allowed us to better assess who was working on which part of the project and what was left to do by the deadlines. As well, daily communication kept us on top of all the deadlines for the overall project. So the design for the login. So this is a simple login page, and we just ask the user to input a username and a password. And if the user provides the correct information, we will let them through to the main game board. And if they don't put anything for the username and password, we alert the user saying that nothing was inputted and reload the page. So I'm gonna let my partner for the project, Tori, take over from this slide and talk about the design of the game board.
Hi, everyone. I'm gonna start by talking about how we designed the main game board for our Game of Life. So the game board design began by generating a random board that would display when the user loads into the main gameplay page. We completed this by designing a table, which is displayed inside a board div inside our HTML. And the board will randomly generate a value that will be displayed on each generated cell on the board. So to break this down a little bit more so you can kind of see how it works out, we have this setup function, which is called at window load through our JavaScript, where we query this board div by its ID. We create a element or a table inside this board div, where we then create rows, and then inside those rows create columns, which makes a cell. The cells are then given an ID so we can reference it later. And by using a get random integer function, which has a floor of 2, we either get a 0 or 1 returned. If we get a 0, we set the class to dead. If we get a 1, we set the class to alive. And then we basically update this table to the board where it can be showcased, as well as we display the generation. At setup, the generation is going to be 0. So that way you can kind of see what generation of the pattern you're on and see this randomized board of alive and dead cells when you start. So as well with the design, we needed to implement the game of life rules that it follows with cell life and death. So we look at each row and each column inside the current generation. The current generation is a 2D array that saves the state of every single cell inside the current game board. And then the code checks the amount of neighbors that the cell has. And so we check this by looking at the 8 neighbors that surround the cell. And if there is a live cell there, we add 1 to the count. If there's a dead cell, we add nothing to the count. And then based on the number of neighbors the cell has, the next generation of the game will be respectively updated with a 0 or a 1 representing the death or the life of a cell. So as you can see, the rules here are implemented as if a cell has either less than 2 neighbors or greater than 3 neighbors, it dies by underpopulation or overpopulation respectively, which sets it to a 0. If it has 2 or 3 neighbors, it gets to live, so it sets it to a 1. And if a cell has exactly 3 neighbors, then it will be born. So cells are generated. As well for this, we wanted to include user accessibility to better be able to play the game or see how the game is played. And so we included 5 different buttons that help control the game. We included a start button, which allows the game to begin by incrementing 1 generation at a time until it's told to stop. We have a stop or resume button, which either ends the game once it's pressed, or if you click it again, resumes the game from a pause state. And then you can click that button again to once again stop it. We included a reset button. The reset button resets the board from the beginning in order to allow another game to run. This is really helpful if all of your cells die within the first 3 generations due to under or overpopulation and you have nothing left to look at. We included an increment 1 button, which allows the user to choose to increment the game by 1 if it's on pause so they can take it slowly step by step and analyze what's happening. Or if you want to, skip and see what happens at the end, you can increment by 23 generations and see it 23 generations ahead. And so for the last part, the thing that makes our project a little different from all of the other Game of Life implementations out there is that we have a pattern generation. So pattern generation is completed by having a select drop box in the HTML, which calls a function to generate the correct pattern looked for by the user. Once that pattern is identified, a function will call, the correct generation function. And then with this, the board's display is updated to showcase this pattern. So when the play button is hit, it can be analyzed what this pattern is doing. We show still life and oscillating patterns, and I'll showcase those once we get to the demonstration. As you can see by the code right here, we're generating the oscillation pattern of a blinker by looking for cells without any neighbors. If it has no neighbors, then we create the oscillation pattern, and then we set every other cell that is not part of that oscillation pattern to 0. So let's get into the demo of the site, shall we? So this is our site upon login. And so what you can see here is that you are asked to provide that username and password. So I'm just going to put in my username and a password and click the login button. And once we click the login button, it tells us we logged in successfully and we are taken to the main page. Once we're here, you can see this board is randomly generated upon loading. So there's a game ready for you to click the start button and watch what happens. So as you can see, it starts generating. It gives us what generation we're on. And I can hit the stop button right now and it pauses the game for me or stops it where it's at, and I can analyze generation 8. And then I hit the resume button. It keeps going and I can see, more patterns generated. I can hit the stop button again and stop it for good to reset. And so we'll do that right now. So we'll reset the game. If you want to see it as well, you can increment the game once, and there is 1 incrementation of the game, 1 generation. And if we hit increment 23 times, we can see where the game is at the incrementation at 23 times further. So you can see there's a couple still life block patterns here. We can increment once again and see what happens and see as it continues to change, which right now it doesn't because all are still life patterns. So if we reset the board again, we can find that we'll start a block pattern now. So we're going to select a block pattern. We can hit submit and we can see 10 generated blocks. If you were to hit start on this code right now, you would see that there wouldn't be any movement because the block pattern is a still life pattern that is generated. And so if we reset the board again, we should be able to select a different pattern, such as a blinker pattern, or let's go to the beacon pattern. That's the next one on the list. We can hit the beacon button and then click submit, and it'll showcase to us these beacon patterns that start at the beginning. And so if we hit the start function, we can see them start to blink back and forth, and some of them were a little close to each other, so they started to merge. But you can see through this one and through this bottom one that they just blink back and forth and continue to oscillate forever back and forth between themselves. So if we stop that one and reset the board again, we should be able to see the blinker patterns show up. So if we hit submit, we can see our baseline starting points for blinkers. And if we hit start, we'll watch as these blinkers oscillate as well during the board, and you can kind of see how these patterns are generated and move and how they don't ever really change unless there are other elements on the board to run into them and help change them. So we can stop it again, reset our board to start another game implementation. And then if you're done and you've seen everything you want to see, you've tested every test. You can also turn cells on and off by clicking on the cells. So you could run very specific tests yourself, set very specific patterns. You could set a high on the board like I'm doing right now and see how that runs and what happens with it. But if you're done, if you've ran every test in the world that you can think to test, you can log out and you'll be brought right back to the login page. So to go back to our presentation now, we tested this by completing different tests throughout the project to verify all aspects were working. Some different test cases were applied. We tested all new features on the app by creating a new branch on the project at the GitHub page and pushed our codes to it so the other group member had to test and verify that it was working. To fix a bug on whether you could resume the game or not once it was stopped, a switcher was added to help keep track of the start resume when it was pressed or when the stop button was pressed to help us, keep track of, are we starting again or are we resuming again? Do we need to increment or do we not need to increment? The patterns, as you could see during the demo, sometimes overlap upon generation, making it hard to spot what pattern was supposed to be there originally. The console outputs were used in order to verify what rows and columns would overlap and allow for more accurate spacing to be added between the rows and columns. And both of us communicated through Discord to keep each other updated with what we were working on and used Discord to communicate and when a bug was found so that our partners could look at it as well. We did try and do a test case to make sure the login was working as expected by making sure that, if a random generation of a null string was put through, that the person was not allowed through to the main page. So we'd like to thank you for listening in on our presentation, and we hope you enjoyed our Game of Life implementation. Thank you again.
Goodbye.